Hello everybody, welcome to my presentation. Today we're going to be learning about tennis and how it relates to physics. Firstly, velocity. Velocity is movement in a direction. When something has velocity, it is moving in a direction. Your frame of reference is the point that you are measuring your velocity in relation to. Acceleration is a change in velocity over time. When you hit the tennis ball with your tennis racket, it accelerates the tennis ball. When it is hit by the other player, they accelerate it in the opposite direction. Now I have a video. Now you can see it has velocity in her direction, and then she applies negative acceleration to it and pushes it in the other direction back at her opponent. I may or may not have skipped a slide. I certainly did. Okay. Now, Newton's laws. The first law is conservation of motion. That means that something will not change its motion unless an outside force acts upon it. For example, say you were to hit a tennis ball with a tennis racket. That tennis ball would continue moving until it was acted on by gravity, or air resistance, or hitting somebody, or hitting your racket. The second law. The second law is force equals mass times acceleration. Now, a tennis ball has very low mass, meaning that decreases the amount of force that it is required to hit to move it, compared to if it were very heavy, like a bowling ball. If you tried to hit a bowling ball with a racket, you would not be able to move it. Third law. Every action has an equal and opposite reaction. That means when you hit on the tennis ball, it applies a force back on your racket that is equal to how hard you hit the tennis ball. Velocity. Once more. A projectile is an object that is being affected only by gravity. No other forces are currently acting on the object. That means it is not being pushed or pulled. It is simply being brought down by gravitational forces. Much like a tennis ball is, in between it being hit by your racket and it being hit by the other person's racket. While it is in the air, it is considered a projectile. Now, horizontal velocity and vertical velocity are separate. This means that no matter its vertical velocity, it will fall at the same rate, meaning if you take the tennis ball and you hit it really far, it will still fall just as fast as if you hit it really soft. Combined velocity. This is the idea that velocity is relative to your motion, or the motion of another object. Meaning, if you measure something from where you are, combined velocity means that, for example, if something were moving 5 meters per second and it saw something moving 6 meters per second in the same direction, it would observe that second object as moving 1 meter per second in that direction. This is because it is moving too. And so things appear to move less of a distance. Friction. Friction is the force of objects rubbing against one another. This means that it is because things are slightly, on a microscopic scale, not completely smooth. So when you rub things together, those small non-smoothnesses will kind of grind against each other in a way. Now, of course, mu, your friction coefficient, is the force of friction. So, for example, something like sandpaper would have a high friction. Something like an oiled up man would have a low friction, divided by normal force, which is usually gravity. So, of course, when you increase your friction or gravity or something, you don't actually increase your coefficient of friction, because it will also raise the other thing at the same rate. Last but not... Maybe this one's last? No, not last. Not last and not least, elastic potential energy. Now, elastic potential energy is the amount of energy required to stretch an elastic object a certain distance. For example, it requires a certain amount of energy to stretch a tennis ball when it impacts the ground. And, of course, exerting that energy causes it to stop. Or, in some cases, it causes it to bounce. Now, actually last but not least, energy. Energy is gravitational potential energy equals weight times height. Now, what does this mean? Well, this means that the heavier something is, the higher its gravitational potential energy. And the heavier something is, the higher its gravitational potential energy. Meaning, if something is very fat and it is up very high, it has very high gravitational potential energy. Now, kinetic energy, this one's a doozy, because this is half of your mass times your velocity squared. Energy is conserved. Now, this is the idea that, well, it's actually a law. It's for sure real. When energy is used, it is conserved. This means that you cannot create it, nor can you destroy it. How does this relate to tennis, you may ask? Well, when you hit the ball, and then it stops by hitting the ground or something, it lets off energy in the form of perhaps mechanical energy, perhaps even heat energy, too. Work. Work is force over a distance. Now, if you recall, force is mass times acceleration. So, it's mass times acceleration divided by distance. Now, work is important because force is just an instantaneous thing, and actions take distance and time, and you have to do them. So when you have your distance, it really does things for you. That's the end of my presentation. I hope you enjoyed.